Right. So, a very good evening, everyone. We'll be starting our presentation sessions now. Please raise your hands and we'll go by the order of raised hands. So, as I can see, first we have Byleen Janet Roy. Yeah, you can unmute yourself.
Am I audible?
Yeah, you're audible.
Shall I start to present, sir?
Yeah, you can share your screen.
Shall I start, sir?
The
Sir, I'm a,
screen is not visible.
oh, one sec, sir. Yes, sir.
Yeah.
Yes, sir. Is my screen visible, sir?
Yes. Man in the middle attack, right?
Yes, sir.
So, yeah. Okay, you can start now.
A very good evening to one and all present here. And myself, Byleen Janet Roy, and I'm doing my cybersecurity intern at Hackweather. And the task which they provided me is to initiate a man-in-the-middle attack using ARP spoofing. I let you all know what is meant by man-in-the-middle attack as well as ARP spoofing as the slide goes. Let me share the agenda of the presentation. First we'll let you know what is meant by MITM, that is man-in-the-middle attack. Then how it is performed, then tools used for MITM, how it can be prevented, what is spoofing, how ARP spoofing works, and conclusion. And let me go to the next slide. MITM is nothing but the man-in-the-middle attack. It involves three people, or it involves three components, to be honest. What are they are? The client, the hacker, and the server. Yes, basically a hacking technique involves three people into it. That is the client, the server. We'll be having a hacker in between, which is known as the man in the middle. The middleman is known as the hacker here. And what is the role of the middleman? What will he do? What will he or she will be doing there? What is the role of the hacker here? He'll be intercepting the communications. I'll let you all know how he'll be doing this sooner as the slide goes. He'll be intercepting the communication. He'll be sniffing through the packets and he'll be analyzing through it. We all know what is meant by packet. A packet is nothing but a small sized data. The communication between the system is done by sharing the data, which are divided into packets. A group of packets together will form the data, right? So small packets will be sniffed by the hacker who is in between the systems of the client and the server. That is how it works. And the manipulation of data. That is the main purpose of hacking. A person hacks into a computer either to steal the data or to manipulate the existing data. And the spoofing identities. Yes, the meaning of spoof is to imitate or mimic something in a playful or deceptive manner. Either he may be playing with someone else, for he may be tricking or pranking someone, or it may for intentional purpose and so on to hack into a system and to steal his data or manipulate his thing. And this is the scenario of it. Let me start by telling a story. First, without man-in-the-middle attack, how the regular system works, how the regular system works in transferring of data. We'll be having the client and the server. The client will be placing a request. In turn, the server will be responding to it. This is how the basic networking structure between the client and the server works. So there is no middleman here, right? There is no hacker here. This is how the system works in a peaceful manner by not having any leakage of data. Maybe there may be a leakage of data by any other attacks, but I'm focusing here only about the man in the middle attack. There is no middleman here, so the flow of way is peaceful here. So how the man in the middle attack will be happening here? We don't have a middleman. What if we have a middleman here? Yes, here we have the hacker here, the client and the server. In between, we will be having the hacker. How this process will be working? The hacker here, why is he at the middle? I'll let you know. Because the hacker will be acting as an intermediate portion. He will be receiving the request, he will be forwarding the request to the server. He'll be receiving the request from the client and forwarding it to the server. In turn, he will be getting the response from the server and he will be forwarding it to the client. I use the word forward here. I'll let you all know why I use that word. So the hacker will be acting as an intermediate person so that he'll be forwarding those packets to the server and he'll be receiving, so that in such a way he will be hacking through the client system. How can they hack into the client system by just forwarding the packets? You may ask me a question. But the answer is really simple. What if you are going into the Instagram web page? You are going to the Instagram web page and you are trying to signing in into it, right? I'll be but Instagram is an HTTPS, that is Hypertext Transmit Protocol, which is in a secured manner. But guess it is an HTTP regular page. We'll be logging in by giving a username and the password, right? What if I enter the username and password and I click to sign in? So it will be passed to the hacker first, then to the server. He'll be knowing that I'm trying to log in into this IP address. I'm trying to log in into my Instagram account using these credentials. So he'll be taking those credentials away from me and he'll be hacking it, right? So in this way, the MITM scenario works. And he can also do many things. He can also peep into your system by knowing the credentials and stuff, right? So in such way, MITM scenario works. And how it is performed. Like I have said earlier, we have certain steps to perform MITM attack, right? That is what I have mentioned here in steps. First, whatever the attack be, we have to prepare. We have to prepare the system. We have to set an attacking system so that it should be connected to the same local area network, which should be seen here because we are performing a man in the middle attack. So that we have to be connected in the same local area network, so that we can locate the target as well as we can have him as a victim and we can perform our attack by picking up the gateway. That's it. And I used the word forwarding here. Enable IP forwarding is the second step. Why should we forward the IP address here? It is because we have to enable the IP forwarding to the intercepted traffic to flow through the attacker system. We are nothing but we are cheating the client system so that we are the one to whom they have to share, and we will be forwarding it to the server for not disrupting the connection. So in such a way, it works. The IP forwarding works here. And identify the target and gateway IP address. How this works is determining the IP address of the target victim and the legitimate gateway on the local area network. That's it. To have a good flow of connection. And ARP poisoning and spoofing. It is nothing but the address resolution product. It is address resolution protocol. It is just a communication protocol. It is used for discovering the linked layer address, such as a MAC address, and associated with a given internet in the layer address, typically an IPv4 address. Okay, what can be done by using ARP poisoning? First of all, address resolution protocol is used for transferring the packets to this IP address to another IP address by having a unique MAC address for each system. What if I manipulated the system so that I gave my IP address to be the one to which the data should be sent? It will be sending the packets to me instead. This is how the MITM attack works. That is man in the middle attack works, and that is what is known as ARP poisoning. We are poisoning the given gateway IP address as well as the given IP address, and capture and manipulate the traffic. Yes, we have to manipulate the traffic. Right? That is how we can create a good attack and so on. And forwarding the traffic. We receive the packets from the client system. And what you have to do, we have to forward it to the next, we have to forward it to the server, and we have to maintain a good connection so that there will be no doubt spawned over there, right? And intercept and manipulate, it's our optional thing. Like how I said for an example, like the hacking the Instagram password by using ARP poisoning, and we have a tool known as Wireshark. I'll let you all know what is that. And we have to clean up. We should not leave any trace over there, right? That is how the hacking works. If you are going to if you are stealing someone's data, we should not leave any trace over there so that they'll not find us again. That's how a basic hacking works, right? In such way, it is performed. And ARP, I have given the definition of the basic ARP over there. It is a networking protocol used to map the IP addresses to their corresponding MAC addresses, facilitating communication between the device on the local network. That's it. In the local network, it works. And tools which are used for performing the MITM, that is man in the middle attack. These are some of the tools. ARP spoof, that is used for spoofing using the ARP address, and that is address resolution protocol. Ettercap is the name of the tool. It can be installed in Kali Linux, and it is used for performing an ARP spoof. And BetterCap, can enable, and Wireshark. Wireshark is a very famous tool used for performing the MITM. It is basically used to stand as an intermediate section to receive the packets from various different networks, and what that packet has and the data look into it, we can look through it. using Wireshark. It is available for both Windows as well as Linux and so on, and Mac too. And SSL strip, MITM-F, that is man in the middle framework. We have various frameworks like Metasploit and so on. Such framework is man in the middle framework. ZAP, that is OWASP Z attack proxy, responder, and DSNF. DSNF is also a very famous tool used for doing many attacks. It is used for capturing the images from the screen. Let me give an example. If you are visiting, if I'm performing a man-in-the-middle attack into your system, and you are viewing some images, DSNF will be used to pick those images from your system, and I can see what you are seeing as an image. That's it. And how can we prevent the MITM attack? It is very easy. We should have an encryption secure protocol. Why should we? It is a basic thing to have, right? If you have to keep something safe, we should have an encryption system over there, so that the communication of network will not be picked through by other people. That's how WhatsApp work to write end-to-end encrypted, so that the middleman will not be entering and can't hack our devices. Certificate validation. What is a certificate? We can use the concept of digital certificate over here, which can be generated by using hash function. We computer science students might know what is meant by hash, right? Hash is nothing but a unique code generated by using a function called as a hash function. That's it. And network segmentation isolation, ARP spoofing protection, public key infrastructure. I've used this public key infrastructure for logging in into the PuTTY system. If you have seen what is meant by DOS attack, you might have known what is meant by public key infrastructure. And strong authentication, identification, verification, and so on and so on. And the regular security audits and penetration testing. What is meant by penetration testing? It is nothing but if you know to hack something, you must also know how to prevent it. In such a way, we have to test something by penetrating into it. That is known as the penetration testing and nothing else. And spoof. I told you what I told you to explain. I told you that I will explaining about what is meant by spoofing. A spoof is nothing but to imitate or mimic, as I said earlier. It might be in a humor sense, or maybe satire, or maybe deception. It is doing something in a fake manner or in a false version. That's it. What are the types of spoofing? We have some types of spoofing here: email spoofing, MAC address spoofing, IP spoofing, and caller ID spoofing. Spoofing is nothing but forcing something, right? We can do it by using these mediums like email or maybe MAC address or maybe IP or maybe caller ID. That's it. What is ARP spoofing? As I said earlier, ARP spoof is a cyber attack that involves manipulation of the address resolution protocol, that is ARP, which holds the address like MAC addresses and so on for having a perfect link between the communication of the two systems, right? So that can be intercepted by using the concept known as ARP spoof. It is a tool used. That's it. That should be connected in a local area network. And this is the screenshot of me performing ARP spoof, and through which I'll explain what has been done. This 192.168.0.1. This is the IP address of my Kali VM machine. And this 192.168.0.106. This is the IP address of my this is the IP address of my Kali Linux machine, and this one is the address of my regular Windows machine. What I did here is this has one unique address and this has another one. This is after performing the ARP. This has another one. After performing ARP spoofing, what happened here is you can see here 800278349 and C3, 800278349 and C3. Both the physical addresses are same, which means I just convinced the system that the gateway through which it should enter and exit is through my Kali machine. That is how I convinced the system so that the ARP spoofing has been done successfully. That's it. And I told you that I will be explaining about Wireshark. Wireshark is nothing but it is a software, or it may be a framework which is used for performing the man-in-the-middle attack. To be simple, but it just receives the packets which has been shared by the clients and which has been received from the server, and we can look into the packet what has been done by the client here, so that I can easily see what he has typed there. It might be a password or it might be a credential or so on and so on, so that I can just steal them, right? That is how the Wireshark has been used here. And yes, we have I'm concluding my session, and we have seen what is meant by MITM, that is man in the middle attack. We'll be having a man in the middle who is also known as the hacker, who will be peeping through the systems of the client by just acting as the middleman between the client and the server. He'll be receiving the package, he'll be forwarding through using the IP forward concept, and he'll be working through. He'll be just manipulating or stealing the data. That's it. And we saw how it works. We saw what is meant by spoofing and what are the types of spoofing. What is ARP spoofing? That is address resolution protocol spoof, and Wireshark, how Wireshark is being used, and prevention of man in the middle attack. And this is the reference which I used. I referred these attacks from YouTube and many other YouTube channels to know deeply how DSNF, how MITM attack is used, and how Wireshark has been used, and so on and so on. Any other questions? And for contact, you can just text me through my email, and I'll reply you soon. And this is question time. If you have any question, you can ask me. Thank you, sir.
Right. So I believe your presentation is over, right?
Yes, sir.
Right. So see, let's talk about the demo first. Did you actually perform the demo?
I can't perform the demo as I have to use the VM here, sir.
Okay.
It will be extracting more memory from me.
Yeah, because earlier presentation on this topic, I never saw demo. So I thought there might be something new, but still you added snippets of your demo, which is good enough.
Yes, sir.
And see, your presentation was your the themes you use in your presentation in the formatting part. They are very good, very good, and the way you presented, it was properly well structured. Everything was fine at the right place. Since you are taking Q&A, right? Questions,
Yes,
right?
sir.
Right. So, which comes first, ARP spoofing or ARP poisoning?
ARP spoofing will be coming first, sir. Only then we can do the poisoning.
Right. So, tell me in brief idea about both the terms, both the ARP.
Okay, sir. First of all, through ARP spoofing, what we'll be doing is we'll be convincing the system. Like he should send the package to me, and in turn I'll be sending it to the server, and like that. In ARP poisoning, what we'll be doing is we'll be manipulating the data. That is, we can read the unencrypted passwords and so on, so that we can steal the data from it. That's it, sir.
Right. So, yeah, the whole task runs to around these two things only. Fair enough. As I said, the presentation was very good, very well delivered. PPT was good as well, and there was a good hook story. So, in all, the presentation was very good. That's all.
Thank you, sir.
Right.
Thank you so much. Shall I stop presenting, sir?
Yeah, you can. You had second presentation scheduled for today, as I can see.
Yes, sir. This one is scheduled for today, MITM.
Yeah, and there is another one which is scheduled for today.
That is done by mistakes. I asked in technical support. He
Okay.
told me to done sequentially.
Okay. Okay. Then that's fine.
Okay, sir. Thank you, sir.
Sure. Right. So next we have Pratheek Shetty with us. Yeah, Prateek, do you have a presentation?
Yes, sir.
So you should be raising your hand, right?
I joined it. I didn't see that, sir. Sorry.
Okay. Yeah, sure.
Is the screen visible, sir?
Yes, it is visible. Prescriptive analysis. Okay.
Good evening, everyone. I'm Pratheek Shetty. I received the task Prescriptive Analytics in the project Understanding Descriptive, Diagnostic, Predictive, and Prescriptive Models. The objective of this task is to perform prescriptive analytics on the dataset, to visualize the data using appropriate charts and graphs, to evaluate the solution using appropriate metrics. Consider the situation. Imagine a businessman running a thriving company faces a puzzling dilemma. Without prescriptive analytics, he relies on historical data and gut instincts to make critical decisions. He gets short-term success, but as the business grew, he encountered supply chain bottlenecks, inefficient resource allocation, and missed opportunities for expansion. His inability to optimize processes eventually led to lost profits and frustrated stakeholders. The story highlights why prescriptive analytics is necessary. Prescriptive analytics offers a data-driven solution to this predicament. By utilizing historical and real-time data, we can predict future outcomes, provide actionable insights, and recommend optimal courses of action. This enables the businessman to make informed decisions, maximize efficiency, and achieve sustainable growth. Need for prescriptive analytics. It helps in providing informed decision making as data-driven choices based on predictive analytics improve business outcomes and reduce reliance on intuition. It helps in providing competitive advantage as prescriptive insights foresee trends, giving a competitive edge to adapt strategies and stay ahead. It helps in providing resource optimization as efficient allocation of resources like inventory and finances, enhances productivity and reduces waste. It helps in providing real-time responsiveness as promptly reacting to changing market conditions through real-time data ensures agility and adaptability. The contents of the task, it included importing libraries, dataset handling, data exploration, detection of missing values, descriptive statistics, data visualization, predictive analytics, and prescriptive analytics. Importing libraries. The libraries were Pandas, NumPy, Matplotlib, Seaborn, Lazy Regressor, LSTM, Sklearn metrics. Pandas is a library for data manipulation and analysis that provides powerful data structures and data analysis tools. NumPy is a library for numerical computing in Python, providing efficient array operations and mathematical functions. Matplotlib is a plotting library that enables creation of 2D visualizations and graphs. Seaborn is a data visualization library built on top of Matplotlib, providing a high-level interface for creating attractive statistical graphics. Lazy Regressor is a sklearn wrapper for several fast baseline regression models. LSTM is a deep learning library for sequential data processing. Sklearn metrics provides functions for evaluating models. Dataset handling. In this dataset, there was a real-life historical product demand for global manufacturing company with thousands of products. Data included various product categories and warehouses. All this information was encoded for privacy. I'll show you the data set. As you can see here, the first column is product code. There are around 2000 values, I think, if I'm not wrong. There's warehouse. The second column is warehouse. There were 4 different values. One is J. There's one more warehouse A. There's one more warehouse S, and one more warehouse C. Then there's product category. Product category were values from category. There was 001 to 033. The date was the date when the order was issued. And order demand is the quantity of order. Data exploration. The dataset contained 1,037,336 rows and 5 columns after deletion of missing values. The original data types were of product code, warehouse, product category, date, and order demand. All were of object type. But for prediction purposes, we have to change order demand to numeric data type and date to date time 64. Detection of missing values. the data set at 11,239 rows with missing values in the date column, which was subsequently removed. The other columns did not have any missing values. Descriptive statistics. The warehouse column had 4 unique values, like I said, warehouse J, A, S, and C, with warehouse J having the most frequent values of around 764,447 values. The order demand column showed significant variability ranging from 0 to 4 million units, with the mean of approximately 4,948.38 units. Data visualization. This is one of the graphs. This is a count plot for the different warehouses. The first warehouse was warehouse J with the highest count, around 7.6 lakhs. Next was warehouse A. Next was warehouse S, and there's warehouse C. This is a line graph. On the left hand side, you can see is the actual line graph for the dataset after deletion of missing values. Here, though, one thing that's to be noted is the duration between 2011 to 2012. There, the trend is different from the other years, as we can see from the line graph. This could be due to several reasons. One reason could be because the company probably just started between 2011, just started in 2011, and they didn't have a big customer base. So they didn't have a large order demand. Or the other reason could be because there was no proper data management between 2011 to 2012. So these values can be considered outliers. So I remove these values. So prediction I performed between 2012 to 2017. As you can see on the right side, the right graph is between 2012 to 2017. The values between 2011 to 12 were deleted. Further, I divided the values in according to month wise, because as in the previous graph, there are many data points with various with very large variances. Some were around 0.5 to the power 6, some were 4 to the power 6. So getting a prediction just based on those values is not easy. So I divided into month-wise data. So the first data point here you can see is probably 2012 January. Second data point would be February and 2012, and so on till 2017. Here in this graph, you can see that around in 2015 to 16, the order demand rose the highest, and then again it decreased, and before that as well it was lower. Predictive analytics. The algorithm I used is bidirectional LSTM. It's a neural network of RNN type, you can say, with two layers of 128 units each and a dense layer with 1 unit. LSTM, or long short-term memory, is a type of recurrent neural network, or RNN, like I said, designed to handle long-term dependencies and sequential data. LSTMs have memory cells that can retain information over time, allowing them to capture patterns and dependencies in sequential data, making them well suited for time series forecasting and natural language processing tasks. Bidirectional LSTM, a variation of LSTM that processes the input sequence in both forward and backward directions. This means that the input data is presented to the LSTM cells in its original order and also in its reverse order. By doing so, the model can capture dependencies not only from the past information but also from the future information, enhancing its ability to understand context and dependencies in the data. In summary, LSTM is a specialized type of RNN for handling sequential data, and bidirectional LSTM further enhances the model's understanding of temporal dependencies by processing data in both forward and backward directions. This makes bidirectional LSTMs particularly effective in scenarios where information from both past and future context is essential for accurate predictions or understanding data patterns, like in time series analysis. The metrics used were mean absolute percentage error, or it's known as MAP. This is the average percentage difference between predicted and actual values. I got a value of 3.85% here, and for LSTM. The other metric I used was root mean squared error, or it's known as RMSE. It's the square root of the average square differences between the predicted and actual values. Uh, yeah, here if you just see the value of root mean square error, it looks like a very large value, which is 3,884,000. But later I'll show you in the demo, when you compare it to other values, it's pretty small. RMSE is also interpretable in the same units as the dependent variable, and a lower RMSE value indicates better model performance. This is a graph of the test data set with the predictions. Prescriptive analytics. It can be of two types. One is of data analysis and evaluation, which is like after predictive analytics, prescriptive analytics assesses potential outcomes and their impacts using historical and real-time data. The second is of recommendations and actionable insights. Prescriptive analytics suggests optimal courses of action, empowering business to make informed decisions and drive desired results. I performed the prediction here in Python notebook, Jupyter notebook. Here I imported the libraries. I read the library. Gives the first 5 rows of the library. Here I read the data set. This is the first 5 rows of the data set. These are the last 5 rows of the data set. Here, yeah, df.shape gives the number of rows, which is 1,040,575 rows, and 5 columns. The 5 columns of product code, warehouse, product category, date, and order demand. Like I said, all of them are object type. I later converted order demand to numeric type and date to date time type below. I detected missing values. Date had 11,239 missing values. These were dropped, and I checked them again. There was no missing values. The new shape was 1,037,338. Sorry, 1,037,336 rows and 5 columns. I changed the order demand to numeric type, int type data, and date to date time type. As you can see here, df types, it gives order demand as int64 and date as date time 64. Then I performed descriptive statistics. Product code had totally around 2,160 values, different values, unique values, with product code 1359 having the highest value count. The warehouse had 4 different values, which is warehouse J, warehouse A, warehouse S, and warehouse C, with warehouse G having the highest value, like I said earlier. Product category had values from were categories from 001, 001, category 001 to category 033, with category 019 having the highest value count. Order demand, you can say that the minimum value was 0.00 and maximum value is 4 million, like I said earlier, and the mean value is 4,949.38. The dates were between 8th January 2011 to 9th January 2017. Here I perform the data visualization. Like I showed earlier, warehouse J at the highest, warehouse A at the next highest, and then warehouse S, and then warehouse C respectively. These are line graphs between order demand and date. Like I earlier showed, values between 2011 and 12 do not match with cannot be used for prediction purposes because it remains as an outlier between, from the other values. Here I remove the values between 2011 to 2012, and this is a new graph between 2012 to 17. I made a new data frame known as a new DF3 with just two columns, date and order demand. I made them, I divided them into monthly data here. So there are just 61 rows remaining. And as you can see here, all values are like around between 74 million to around 100 million as such. This is the graph like I showed earlier. So line plot between order demand and date for monthly data. Then I performed a lazy regressor. Lazy regressor is basically a Python library that provides simplified interface for implementing machine learning regression models. Lazy regressor can be a helpful tool for quickly exploring and comparing the performance of multiple supervised algorithms. Here you can see the RMSE values of the best model was according to lazy regressor, which is NUSVR, is 4,511,572. From here, I performed LSTM. I added four different layers. Two of the layers were bidirectional LSTM, and two layers of dense. I used a training ratio of 0.9. It's -7 here. That's 7 data points are in test data set, which is a 0.1 ratio. Each epochs were calculated. Here, this is loss per epoch. They just variances of values in each epoch as such. These were the prediction values that I received for order demand predictions. For the 53rd data point, it was like for 84 million, I got 83 million. For 88 million, I got 83 million. And similarly for the other data points. And this is plotted in this graph as well. These are the metric values I calculated. Mean absolute percentage error I got was 3.8%, like I told earlier, and RMSE value I got was 3,884,000. Now this value 3,884,000 looks very large, but compared to values like 83 million, as such, it's a comparatively smaller value, and that's why this RMSE value can be considered good. Conclusion. I developed a robust LSTM based model for order demand prediction, achieving fairly accurate forecasts. Through extensive experimentation and hyperparameter tuning, I optimized the model's architecture to deliver reliable and actionable predictions. While optimization based on the dataset alone is challenging, leveraging order demand predictions can guide inventory management, preventing overpurchasing and optimizing stock levels in the market. This is my reference. I took the dataset from this link. If there's any questions, I'm ready to answer them.
Right. So talking about the PPT first, since it's an analytical task, so graphs and everything was very necessary, and you did meet up with every graph, all the flow charts and graphs, and then the texts, they are all structured properly. Comparing to the last presentation of yours, this one was much better, like 10 times better than the last presentation. Then the demo part which you showed, you did explain everything. It's just when you are showing such data, just zoom in the screen, okay? Because you yourself is people
Yeah,
can read. So yeah, so that shouldn't be happening. Just
sure,
zoom in,
sure.
yeah, at least
Yeah.
for like 120%.
And
That will be helpful, right? And the rest, you started a good with a good hook story, creating a scenario, and then explaining what you are going to do in this task, and then went with all graphs, which was very good. And then the last time there was accumulation of data in some slides, but this time it is well structured, well compartmentalized, and from start to end, the presentation is properly maintained and it's well delivered. So I believe this was a very good presentation from my side. Do you have any query?
yes, sir. I wanted for an internship for around 1 month itself.
Mhm.
So this is, yeah, I've completed 1 month by now. So this was my last task.
But the probationary period is for like 2 months.
No, they told we can take it between 1 month to 6 months or something. They're doing. So
How much I can
now
recall,
if I want,
probationary is for like 2 months. But
no, no, not
how many tasks have you completed?
4 tasks I've completed. This is 4 tasks.
4 tasks, right? Right. You can ask in technical chat because how much I can recall, there is like a minimum criteria of 6 to 7 tasks to be presented, and for like 2 months of probationary period. How much
No,
I can recall, you can. They did what?
not so, I just wanted for the thing, what is it, completion letter as such.
Okay,
So, so I was told to click on the request for the completion letter link,
okay, okay.
but then they didn't tell me when to click it after, just after the presentation or after I've given the score for the presentation.
Right.
I think.
After the score, of course, because they'll go for a data check, na, how much you have scored and
Okay,
everything. Yeah. So because that will be displayed in the,
okay.
yeah. So after you get the score, then you can go for the link. Okay.
Yeah. So am I supposed to click on the attendance link? Still, I get the score, or
Yeah,
how
yeah.
is
I mean, what's the harm in getting more attendance?
it?
Yeah. Until the day comes when you click the, till then just keep on marking your attendance.
Okay.
Right. Sure. Right. So we'll wait for others to join. Right. So since we don't have any more presenters with us now, we'll be ending our presentation sessions, and that will be all. Very good evening, everyone. Thank you.